In this video, we are going to write some expressions with variables, and we have two examples here. So this one says, write an expression to represent 7 more than a. Well, let's say we had just a, and we want 7 more than that, right? So we're going to add 7 to it. And it could be either way around, or this could be 7 plus a because of the commutative property of addition. And then our second one says, write an expression to represent 15 less than x. Okay, well, let's have x, and we want 15 less than x, right? So we're going to subtract 15 because this would be 15 less. Notice how the 15 can't be in front and x can't subtract from the 15 because that would be x less than 15. However, if we were to convert this to an addition problem and said x plus negative 15, we could rewrite this as negative 15 plus x. But either way, these are the answers. And now we have two more problems. And these say that we need to write an expression to represent 5 times r. Well, that would simply be r, and then we want 5 times r, right? So we're just going to multiply by 5. And notice how I'm using this dot here instead of the usual like x. But when we're dealing with variables, we try not to use x so we don't confuse the multiplication symbol with the variable x. See, this would look very confusing if we wrote 5xr, right? That would be confusing. So instead we just use this dot, and a lot of the times when we're having a constant number being multiplied to a variable, we're just going to write them right beside each other, right? 5r. And now we need to write an expression to represent 6 divided by b. Well, we could write this like 6 and then the division symbol b. But instead, let's write this as a fraction. I mean, we could say slash 6 over b, right? Because we're just dividing the numerator by the denominator. And now we can move on to a few more problems. So let's take this example. Write an expression for the quantity 7 decreased by b. Okay, so let's start out by saying, what does decreased mean, right? So if we wanted to know, let's use constant numbers, for example. We wanted to have 5 decreased by 2. Well, that would be the same thing as 5 minus 2, right? So saying 7 decreased by b would just be 7, and then take away from that b, right? And we don't know what b is, okay, because b can change. So whatever b is, we're decreasing it from 7. So if b was 3, this value would be 4, right? Because we would decrease 7 by 3, and that would give us 4. Now let's move on to the second problem. We need to write an expression that gives the product of 6 and v. Well, to figure out this problem, we need to understand what a product is. A product is just the end result of a multiplication problem. Okay, and we want the product of 6 and v, and 6 and v will be multiplied since we want the product. So our answer here would be 6 times v, or just 6v. And now we want to find the sum, and let me underline this, the sum of negative 7, right, the sum of negative 7 and the quantity 8 times x. And notice here that I circled two things in two different colors, right, because we're taking the sum. A sum means just adding two different quantities, and the quantities here are separated by and. The quantities are negative 7 and then 8 times x. So let's write this here, and I'll write them in the respective colors. So negative 7, right? Negative 7. And then we are adding, and I'll write this in blue, we are adding the quantity 8 times x. Well, that is the same thing as 8x, but I'm going to write this in parentheses just so that you can see that they are separated, right? So this is the final expression. We are adding negative 7, and then we are adding 8x. And I can rewrite this so that it's a little bit neater. So I can rewrite this as 8x, and then we will just rewrite this as minus 7, right? Because adding a negative number is the same thing as subtraction, and this is the expression. And now let's take the quantity negative 3 times x and then add 1. And this is similar to our last problem, except this time the quantity negative 3 times x is first, right? So this will be negative 3 times x. We could write this, and I'll write this over here. This could be negative 3 times x, but we're just going to write this as negative 3x. So this will be negative 3x, and we are going to add 1 to this quantity. So we're just going to add 1, and I'll underline this, negative 3 times x, and then 1. So we are just going to add 1. Oh, well, that's a little bit messy, but you get the idea. Add 1. And now let's take 6 plus the product of negative 1 and x. And once again, this is very similar to the two we've done previous to this one, but this one's a little bit special, and I'll show you why. So let's once again underline this, right? So we're going to have 6 plus the product of negative 1 and x. So we can write this negative 6 plus the product of negative 1 and x. And once again, a product just means the end result of multiplication. So this will be negative 1x. And notice here that we are multiplying by negative 1. And let me remind you what multiplying by negative 1 does. Well, when you're multiplying by negative 1, what that essentially is going to do is just switch the sign of what you're multiplying it by. Because if you were to just multiply by 1, it would keep the value exactly the same, but now you're just going to take the opposite of that number. So we can write this as negative 6 plus negative x. And when we're adding a negative number, this is just the same thing as subtraction. So here we have negative 6 minus x. Negative 6 minus x. And to finish, let's look at a word problem. So this problem says that Joey works at a bakery, and this week he made 38 chocolate chip cookies and Y sugar cookies. Write an expression that gives us how many cookies he made this week in total. Well, if he only makes chocolate chip cookies and sugar cookies, and we know how many chocolate chip cookies, but we don't know how many sugar cookies, we can write a variable expression that will give us the total amount of cookies he makes depending on what y is, right? So we just need to add up all of the cookies he made. Well, he made 38 chocolate chip, and I'll underline these in different colors, 38 chocolate chip, and then y amount of sugar cookies. So we will take the sum, right? So this will be 38 chocolate chip, and then we're taking the sum to figure out how many he made in total. So plus y, right? Because y gives us the amount of sugar cookies. And here we are assuming that he only makes chocolate chip and sugar cookies, because when we add those together, that will be all of the cookies he made that week. And we are done.